Morning, everybody. Today is going to hopefully be a very short video, and we're going to take a look at some covalent formulas. We've been spending a few days looking at ionic and finding out that it's kind of a tricky minefield to navigate, to be sure when you're writing formulas that you get the right name, or if you're writing names, uh, that you really take a look at the formula and see how the charges are all balanced. Well, we're going to look at covalent today. Covalent's going to be a little bit of a breath of fresh air because it's a completely different system of naming, and it's like 5,000 times easier. But just to kind of put things in context, remember, and I did have a few people ask me about this on Monday after you've done some reading. It's like, how do you know if a substance is going to be bonded ionically or covalently? Probably the easiest way to tell is to take a look at a periodic table and determine what kinds of elements are involved. If it's a bond between a metal and a nonmetal from different sides of the periodic table, then you're talking ionic, like we've been looking at. You're talking a transfer of electrons. Whereas a covalent bond is almost exclusively going to form between two nonmetal atoms. So you're looking at anything on your periodic table that is over on this side of the stairs, and also hydrogen, who likes to hide up here, and we forget that he's a nonmetal too. And remember from when we've talked about it before, in a covalent bond, the prefix co means with, okay, because what's happening is the valence electrons, covalent, two atoms are sharing those pairs of electrons with each other. When we did the stuff with Vespert and the molecule shape lab thing, those were all covalently bonded substances. So keeping that in mind, here's the most important thing you're going to need to know, and it's a chart. So taking a look at this right here, this is a prefix chart. Now, some of these prefixes, don't worry about trying to write this down, because I've got a copy of this in that same post that I put the practice stuff up on, and I'm going to have it for you to look at during our lesson today. Just take a look and focus here. A lot of these prefixes you're familiar with. You've seen these in places like geometry when you're talking about shapes. If it's got 3 sides, it's a triangle. If it's got 8 sides, it's an octagon. Okay. In fact, I'm trying to think if there's any there. I think the only one that you might not be as familiar with would be tetra for 4. And we've already talked about that because we talked about a tetrahedron. Something with a tetrahedral shape has 4 sides. So we're going to be using, when we do covalent formulas and names, we're going to be counting how many of each atom there is, and we're going to be applying a prefix to it. And so all of these prefixes, or prefaces, I guess, I'm not an English nerd, I don't know, will tell you how many of each atom there are in a given substance. Now, the only one that's got kind of a be careful clause is the prefix mono. Okay, mono means 1, but you only use mono in the second element. Okay, if there's 1 of something. So like, if I have something like carbon dioxide, I don't have to say monocarbon dioxide, I just say carbon dioxide. But if I have just 1 oxygen atom, then that would be carbon monoxide. Okay, so I say 1 oxygen instead of more than 1 oxygen, so it would be monoxide or monooxide instead of just saying flat out carbon oxide. And we're going to look at some examples. It's going to make a lot more sense after we do. Let me shrink my fat head down a little bit more here. All right. I'm going to look at a few examples on the slideshow here, just for us to work in general or talk about in general. Or maybe I won't. We'll see how well my writing skills are. So here we've got hydrogen, which is a nonmetal, fluorine, which is a nonmetal. So classic case, we're going to have a covalent compound here. So we're going to have a covalent name. So the way that you name this is you take a look at how many of the first atom we have. We just have one. We take a look at how many of the second atom we have. We just have one. We're going to find my pen here. We're just going to use the name. And so the name of the first one is just hydrogen. Oh, and now you're watching me write with the mouse again. That's fun. Now for the second one, since I just have one, I am going to use the prefix mono to describe that I've got one. So this is going to be mono Now I would say monofluorine, but the other rule that I forgot to mention is the second substance, you drop the ending of that name. So if it's like fluorine, we're going to drop the "ine" off of it, and we're going to add the suffix "ide," I-D-E. And so this right here is hydrogen monofluoride. And that's all there is to it. Actually, that's a lie. That's not all there is to it. If you have this substance right here with just hydrogen and fluorine bonded together, it is hydrogen monofluoride. But if you dissolve this in water, then it's got a different name entirely. And I don't think I'm even going to tell you about that right now. I think we're just going to wait and talk about those when y'all come back after Thanksgiving break. So right now, hydrogen monofluoride is just fine. Okay, how about this one? Okay, my first carbon is a nonmetal, oxygen's a nonmetal, so I don't have to use more than one for the prefix on carbon, so I'm just going to say carbon. Wow, that's bad. Now I've got one oxygen, so I'm going to use the prefix mono for the second atom, so it's going to be carbon. Now I could say monooxide, but that's awkward, so usually it's just shortened down to monoxide. And again, oxygen, I'm dropping the end and I'm ending it with "ide." I know that that's a little bit confusing because it's like, well, how many letters do I drop? Why isn't it carbon monooxide or something like that? And a reason for that is that a lot of these compounds have been known to us for a very long time, and a lot of the roots of this particular system of naming goes back a long way. In fact, there's going to be two molecules that don't even go with this system that you're just going to need to memorize, but you already know at least one of them, and I'm pretty sure you're familiar with the second one. So let's just keep plugging ahead. This is good. So we have As2S4. Now S, you probably already know, is sulfur. But As you might need to look up on the periodic table, and actually so might I. I forget if it's astatine or arsenic. I think it's arsenic. It is arsenic. Okay. So this is arsenic. But this time, because I've got two of them, then I'm going to have to use the prefix for 2. And over here, I've got 4 of these, so I'm going to need to use the prefix for 4. So here's how that's going to look. Okay, I put di on the front of arsenic, and I write diarsenic. Sounds violent. Di means two. 4, the prefix is tetra, so this is diarsenic tetra. And instead of sulfur, I'm going to drop the off the end, and it's just going to be tetrasulfide. Again, I apologize for my clicky handwriting here. So diarsenic tetrasulfide. Di means I've got 2 arsenics. Tetra means I've got 4 sulfurs. It ends in "ide," and I'm done. So, in my opinion, I think that's a lot easier than the ionic system, which is kind of why I saved it for last. Let's look at what happens when you go the other way. What if you're given a name and you have to write a formula from that? Well, you might find this to be even easier. Let's take a look at this. We have trisilicon octafluoride. Okay, so tri means 3. Let's use green. Octa means 8. And if I'm looking at my symbols for these, silicon is Si, fluorine is F. So when I go to write my formula, it's going to have 3 silicons, so it's going to be Si3, and it's going to have 8 fluorines, F8. Okay, look how quick we got that. So we'll look at another example or two, then we'll take a look at a couple that are on the practice problems here, and I'll try and answer any of your questions. We'll save that. We'll save that. Yeah, we are going to save that for right now. We're just going to stick with the binary compounds. So dinitrogen monoxide. Okay, type up in the chat what you think the formula for that's going to look like. Don't worry about trying to make it superscript or subscript or anything. But look at the prefixes and look at the elements. And let's see what you get. While I hydrate. Caffeinate. I'm being a patient teacher. I see a vote for N2O. There's another N2O. There's another N2O. And I would have to say you are N2 correct. Absolutely. So you got that because di means 2. Nitrogen. So I'm going to have 2 N's. Mono means 1. Oxygen. So N2O. Absolutely. See how easy that is? Isn't that great? Okay. How about sulfur dioxide? Go ahead and do that one in the chat. See some votes for, I see some SO2 and some S2O. So let's talk about that. Let's talk about, okay, so the di is stuck onto the oxygen part. So that tells me that I'm going to have 2 oxygens instead of 2 sulfurs. The sulfur, since it doesn't have a prefix, I assume there's just one of them. So you're absolutely correct. It is SO2. Now I want to skip ahead and talk about those 2 compounds that I told you you just need to memorize the names of. There's one of them. Ammonia is NH3, and yeah, you often will just see it written ammonia. If you were to give it a systematic name, then you might call it either nitrogen trihydride or trihydrogen mononitride. It just depends on how you want to approach it. And actually, there is a system for how you approach that, but I'm not going to have you worry too much about that right now. Just stick with calling this guy ammonia. And the other one is good old water. Okay, H2O. Just for fun, in the chat, if we were to have to use this system over here to call water what water's name actually is, what would we call it? Give it a shot. Look at how many of each thing you have. Look at your prefixes. I'm saying some dihydrogen monoxide. Dihydrogen monoxide, absolutely right. So dihydrogen comes from the fact there's two of them. Mono comes from the fact that there's one of these, so monoxide. Absolutely right. So I think I'm happy as far as that goes, as far as, oh, that's another fun one. N2O, dinitrogen monoxide, laughing gas. Let's take a look at some of the problems on the thing. And this you can find and make a copy of. You can either print it out or you can just type, since it's a Google Doc. If you're going to do that, you need to click File, Make Copy, so that it'll save a copy for you. But let me let you. I'll tell you what. In the first 8, I will work 2 of those for you so you can watch me do it. And then I'm going to have you do a couple so I can see if you get it. So give me some numbers. What do you want me to work? Gotta vote for 2. Gotta vote for 1, vote for 9. Another vote for 2. Okay, and votes all over the place here. So I'm definitely doing 2 because I've got 2 votes for it. Okay, there's another vote for 4. All right, so we'll do 2 and we'll do 4. So number 2, hexaboron monosilicide. Let me get my handy dandy chart over here. So hexa, according to my chart, means 6. Okay, the symbol for boron is just B. So I know I'm going to have B6. Monosilicide, mono means 1. Silicide, that element would be silicon, right? So I just have 1. So my formula is just B6Si. Yes. Number 4, hydrogen monoiodide. Oh, this is a friendly one. Okay, hydrogen, since I don't have a prefix, I assume I just have 1 of those. Mono means I have 1. Iodine symbol is capital I. So y'all say hydrogen monoiodide. Okay, then let me throw a couple out to y'all. I would like for you to tell me the formulas for, let's say number 1, and let's say number 5. So go ahead and do both of those, and when you think you've got the answer, type them up in the chat, and we'll see how you do. Okay, fine. Antimony's symbol is SB. There you go. Don't want to have to wait forever for somebody to have to find that. I might cut this part out later when I edit these, or I might just leave it in so that people who didn't make the Zoom have to sit and listen to dead silence while you guys write formulas. Just depends on what kind of a jerk mood that I'm in. Okay, getting some answers popping up in the chat there. Okay. Well, you forgot more than just the R, dear. We'll talk about it. Okay, because you have to look up both elements. All right. So Sb is antimony. The brome right here tells me that's going to be bromine. So I'm going to have both Sb and Br. Okay. And so there's no number in front of that, so it's just going to be one of those guys. The triad tells me there's going to be 3 of those. So yes, y'all who are popping up in the chat, SBBR3, that is absolutely correct. The capital and the lowercase definitely makes a difference. And it is definitely important that you're careful about when you've got a 2-letter symbol that you do capital first and lowercase second. And yes, for number 5, since there's no prefix right there, you just assume one of those iodines. Penta means 5, so you'd have 5 fluorine, so it would be IF5. Good job. We're running longer than I was hoping. We're already up to 21 minutes, but I don't want to rush this, so y'all pick out 2 for me to work on the bottom half here, and I'll be happy to. Let me see your votes. And everybody's going for 12. Okay, I'll do 12. All right. What else? And there's 2 votes for 9. I guess I'll do 9. Okay. So, all right, let's look at number 9. Number 9, P4S5. P, I know, is phosphorus. Prefix for 4 is tetra. So I'm going to start it off with tetraphosphorus. That's sulfur. I have 5. The prefix for 5 is penta, so that's going to be pentasulfide. Okay, easy peasy. Number 12, Si is silicon. 2, the prefix for 2 is di, so it's going to be disilicon. Again, it sounds so violent. And then 6 for bromine. The prefix for 6 is hexa, so I'm going to say hexabromide. Don't forget that all of these have to end in ide. Okay, and you can't see that I wrote that. Okay, but that has to be at the end of all these. All right, so let me pick a couple for you to work. I would like you to do number 10. And I would like you to do, I'll let you do number 11. It'll be boring. Do those 2. Put your answer in the chat when you think you got them. Ah, he fell for it. I love it. So, she fell for it too. Oh no. Number 10 is a little bit of a trick question. Yep, that's the correct answer for number 10. Number 10 is just oxygen gas. You don't have to say dioxide. It's just, it's not bonded to anything else, so it's not a covalent compound. It's an element. See that? And if you remember, does anybody remember the 7 gases that always go in pairs? Remember Hofbrinkel? Oxygen's one of those 7, so you would just call it oxygen, or you just call it oxygen gas. Number 11, let's see your answers on that one. Haley Jones, you're very close with number 11. Not quite. Forgot one little piece. There it is. Yeah. Absolutely right, because you've just got one of those silicons right there. So it would be diboron monosilicide. Okay? Uh, so I think I'm going to go ahead and cut off the stream, and then if you have any questions, you can ask them off camera. But for anybody who's watching this later on, I hope y'all have a lovely Thanksgiving break, and try not to break anything over Thanksgiving.